Welcome to Open Source Options. Today we're going to discuss how we can take raster data and map it to vector data using a process called zonal statistics so that we can display summaries of our raster data for our vector units. So let's jump into that. We're going to jump into it using some NDVI data from Sentinel-2. If you're not sure how to calculate NDVI or how to get Sentinel-2 data, I have videos on that. They'll be linked in the description, so go check those out. One more thing before we get started. I have some courses. There are going to be some free courses coming online at opensourceoptions.com. They're not ready yet, but they're going to be there, so you might want to go check that out. By the time you watch this video, they could be available. Let's jump in to today's task. So you'll notice this raster in the background, this colored raster with the blues and the yellows, browns, and greens is normalized difference vegetation index. It basically shows us where green vegetation is. These black boundaries are watersheds, 12-digit hydrologic unit codes, which is how we define some watersheds. They're smaller watersheds that we define in the United States. What I want to do is I want to take the average NDVI value across each of these watersheds and map that so I can see through time how the vegetation greenness is changing across the whole watershed. So here I have NDVI for two dates. This one's in June 2024. This one is September of 2024. You'll notice in the June when we have some artifacts in here, and these are going to be from clouds, okay? I didn't remove the clouds for this example. You'll want to make sure you're masking out clouds if you do this for a real analysis. But here, we're not going to worry about that. We're just demonstrating the concept. So what I want to do is calculate the average NDVI value in each of these watersheds for June and for September so I can visualize it as a function of watershed instead of continuously. It's very easy to do. We're going to come down here to the search. I'm going to search for zonal statistics. So if we do zonal, we can find this zonal statistics here, and we can double click on that. All right, if you're not familiar with this, you can also go to your processing toolbox, which is this button up here on the toolbar. This is on the, let's close this out so I can see what this is. Not telling me the toolbar. The attributes toolbar, we can go to the toolbox and we can search here for zonal statistics. We're going to get this one here. Now we want to have an input layer, which is going to be our vector data. Here it's my HUC 12 watersheds. A raster layer, let's start with June. A raster band, we only have one band, so we're going to get that there. And then we can put a column prefix on here, which will be added to a column in our attribute table, and then the statistics to calculate. Here we are only going to calculate the mean. You can look and see what all these are, but this is going to be the count of pixels. It's going to be the sum of pixel values, the median value, standard deviation, min, max, range, minority, majority, variety, variance. So we have a whole lot of different things. We only want the mean. You can select multiple of these, and they'll just get added into the attribute name. So let's select OK here and create temporary layer. Let's we can save this into a geo package, which will make it easier, or we can append to a layer, which is what we want to do. So if we append this to a layer, we can come down. I'm going to find where this is. I believe it's in downloads, and I think I saved it in this folder here. So I'm going to just select this layer, which is here, and I can add this right into my watersheds. So let's double click that. Okay, let's go back. So it should get appended to this layer, and let's click run. Okay, and so it's not supported, which may happen. We can do this again. We'll just save to a geo package. I'll save it to the same geo package here, which is my HUC12 selection. And it's going to ask for table name, and we'll call this HUC12 NDVI June. We will say OK, and we will run this. All right, and let's see how this finishes. It should finish pretty quickly here. Okay, so we have that now. Now let's go in and look at our attribute table. So let's open this up. Here we go. We have all the original fields, but if I come to the end here, we now have NDVI June mean. So we have the mean NDVI for every one of those watersheds in June. Now let's go and let's run this for September. So let's run zonal statistics again. Our input this time is going to be NDVI June so that we can append the September values onto the end of it. We're going to get our September raster. We're going to name this NDVI September with the underscore after it. We're going to calculate just the mean. Okay. We're going to save this to a geo package. We're going to save it to this one. Save. And we're going to call this HUC12 NDVI. We'll call it all. So we'll have all the layers. So we'll say OK. And now let's run this. Okay, once again, this will take just a minute to run. Okay, and now we can close this. And let's remove our June layer. We don't need this anymore. We could delete it. We could have saved it as a temporary layer. There's many ways to deal with that. And we can turn that one off. And let's open the attribute table. And if we come to the end, we have our June average NDVI and our September average NDVI, and we can see those values are indeed different from one another. Now we can go in and we can start to visualize these differently. So if we come here and we go to layer styling and we change our single symbol to graduated symbols and we change our value to NDVI June mean, and we change our color ramp to, let's go view all color ramps. Let's do, we can do brown to blue green. Let's try to do, let's do yellow to green. This will probably be the easiest. We can select the number of classes and our classification method. We can do our equal interval and we can classify it like that. Okay, we can also change this to like equal count, quantile, and we can get these various methods for displaying the greenness here. Okay, so we get different values of greenness. Now we can come in and we can change this to September and we can classify it and we can see how that changes. So using these, we can get an idea of how this might change between June and September. So let's go ahead and change this back to June and classify. So let's just take a look here. We can kind of see where the low values are or where the high values are. And now let's go classify. And we can see now that some of those have shifted. The June generally was greener than September was. Okay, so that's how you can easily calculate those statistics for a layer and how you can map your raster data to vector units. Again, hope you found this useful. Go check out the courses at opensourceoptions.com. I think you'll find them useful and enjoy your day.